Since their discovery in the mid-1800s, X-rays have been used by scientists in all kinds of ways. But X-rays from space are blocked by the Earth's atmosphere. So that's a bummer for astronomers. But NASA and the European Space Agency got together to build one of the most amazing instruments of its kind. And that's what we're going to talk about tonight. The Chandra X-Ray Observatory.
We choose to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard.
1, 0, all engine running. Liftoff, we have a liftoff. Listen, Tranquility Base here. The Eagle has landed.
Hi, and welcome back to Orbit at a Tilt. I am your host, Adam Tilted. Tonight, we're going to be talking about one of the members of the Fleet of Great Observatories, the Chandra X-Ray Observatory. And I've got some people here to say hi to. Hi, Amy. Hi, Paula. Thanks for stopping by. It's fun to see you for the live show. Earlier in the week, I showed you an image that was a composite. This is a Crab Nebula. And this was put together from data from 4 different telescopes. Well, 3, actually. Visual, optical, and slightly ultraviolet to near infrared from Hubble. And then X-ray from Chandra. Spitzer is showing the infrared, and we put all of that together and we see this detailed image. So tonight we're going to talk about the Chandra X-Ray Observatory because it's pretty freaking amazing. I've got some cool pictures to show you, and of course this was a shuttle launch, so we're going to watch that. I love the shuttle. In order to detect X-rays, first of all, are highly energetic, and they are created when something dramatic happens. Big explosion. Black hole. Black holes emit X-rays. And as I said, the atmosphere blocks them from reaching the ground. So we need to get high above the atmosphere in order to be able to detect these X-rays. So the Chandra X-Ray Observatory has a very unusual orbit. It's very elliptical, meaning it's not a circle at all. It gets close to Earth on one end and goes way out. In fact, it orbits at 200 times... Wait, is that right? Hold on, let me make sure, because I almost... Yeah, that's right, 200 times higher than Hubble. At its furthest point, it's more than a third of the way to the moon. And that is to get it out of the way of anything from Earth that could potentially be causing any interference. It took a minute to get Chandra off the ground. There were some problems. As I mentioned, it was launched on a space shuttle. It was Space Shuttle STS Mission 93, which was the Space Shuttle Columbia. The launch was scrubbed several times. The first time was for weather. The second time, there were some problems in the display. Hold on, let me see. And then there was a communications loss on the third attempt. When they finally did get into orbit, there still was a problem, and they did not achieve the orbit that they had hoped for on the initial launch. but they were eventually able to get into the proper orbit and deploy the satellite. STS-93 was remarkable for a couple of reasons. One, it was delivering the Chandra X-Ray Observatory, which is the biggest and most powerful X-ray observatory ever. And it was also the first space shuttle crew to be led by a woman. Eileen... Sorry, my notes got covered up. Her name was Eileen Collins, the first space shuttle commander. That was a woman. So let's take a look at this launch. And we're right at the point where they're topping off the liquid hydrogen, and they're about to remove the cone. I'm going to pass through the system audio. Let me know how the volume is, because I want you to hear the communication.
This is entity on air to ground. PLT, perform APU start. PLT, starting APU. NCDR, reconfigure heaters.
Heater reconfig didn't work. CDR, heater reconfig is complete.
Copy.
Ground launch sequencer has terminated liquid oxygen replenished to the external tank and is initiating drain back. T-minus 4 minutes and counting. Final purge of the main engines is now starting. The main engine valves are being opened and being prepared for start. A profile test of the orbiter's aero surfaces has started. The orbiter flight control surfaces are being moved through a pre-programmed pattern to verify they are ready for launch. And the three main engines will be gimbaled and positioned for launch.
Okay, I'm going to speed this up to the big moment. I know, Paula. I miss the fact that we don't launch anything anymore either. With people aboard. Anyways, okay, here's the retraction of the nose cone.
PLT task warning memory is cleared, no unexpected errors. Copy that. Flight crew, close and lock your visors, initiate O2 flow. A few days delayed, but same enthusiastic launch team wishing Columbia's crew success on your mission.
OTC, CDR, we've got our visors and our O2. Thanks for all the great work, and we'll see you in 5 days.
CLS is go for LH2 pressurization.
Hold on, we're coming back.
Very clean. 90 seconds away from launch. Chandra is the next of NASA's series of great observatories following the Hubble Space Telescope and the Compton Gamma Ray Observatory. Liquid hydrogen tank being pressurized for flight. T-minus 1 minute and counting.
I want you to listen. The issue
Columbia will be
happens
launched
about
on an
5
easterly
seconds
trajectory on
after launch.
28.45 degrees
And you'll hear
inclination
them
to the
talking
equator.
about it.
T-minus 45 seconds. Less than 1 minute away now from the 95th Space Shuttle launch. T-minus 35 seconds. T-minus 30 seconds.
25 seconds.
T-minus 20 seconds. T-minus 15, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3. We have a go for engine start, 0. We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
Houston now controlling.
Houston, Columbia is in the roll. We've got a fuel cell pH number 1.
Roger, roll, Columbia, we're looking at. Columbia, Houston, we'd like AC bus sensors off. We're evaluating the fuel cell.
So they, let me turn them down a little bit.
Roger that, Columbia. Looks like we had a transient on AC1.
Columbia is now headed downrange, altitude 3.8 miles. And as we hear, all systems okay. It looks like a sensor on board. 3 engines throttling down, all at 67%.
Columbia, Houston, we are critical to AC2 on the center engine, AC3 on the right. We've lost DCU-A on the center and DCU-B on the right.
Copy that.
And Columbia, Houston, you are go at throttle up.
Columbia, go at throttle up.
And all 3 engines are back at full throttle.
Okay, so what happened was there was a voltage drop in one of the shuttle's electrical buses, and that made one of the 2 redundant main controllers of the engines shut down on 2 of the 3 engines. I know that's confusing because there's a lot of redundancies, but it was just a sensor problem. There wasn't anything actually wrong with the equipment. So they were able to get everything back online. There actually, no, I was wrong about that. There was a problem with there was a problem. There was a hydrogen leak in the number 3 engine nozzle. That was caused when a liquid oxygen post pin came out of the main injector during the main engine ignition, striking the hot wall of the nozzle and rupturing 3 liquid hydrogen coolant tubes. You know, can we just say for a minute how gutsy it is to hop on space shuttle? I mean, I would have done it. I would have done it. Much to my husband's dismay, I would still go, but woo, I mean, the chances of something going wrong. And, you know, when things go wrong, they go terribly wrong. So that was the launch. It did get into orbit. That was on July 23rd, 1999, of course, launching from Johnson Space Center in Florida. I'm going to show you some images from the Chandra X-Ray Observatory, but first I want to let's catch up on the night sky and see what's going on out there. This is what it's looking like outside my house right now. So if you have a clear view of the western horizon, you may be able to catch Mercury. It's very low though, so you'll have to be quick. Jupiter, nice and bright, and Saturn you can see here as well. The moon is next. Oh, sorry, that was Antares. Saturn is up here. The moon is over here next to Mars, closer to the south. They'll be making a nice pair high in the sky. The moon is nearing the first quarter, I think, or did we just pass it? First quarter was, on Tuesday. First quarter was on Tuesday. So we're getting closer and closer to full moon. Get at those telescopes, take a look at the moon. You may be able to Oh, sorry. Thank you, Paula, for correcting me. You know what? I get those confused all the time. Not because I don't know the difference, just because I get them confused for some reason. Yes, thank you for correcting that. The space shuttles launched from Kennedy Space Center in Florida, at the same area where they launched. Sorry, I just had a little computer error. The same facility where they launched the Apollo era, and where they are currently launching SpaceX now. So the same facility. Okay, so did you know that I'm going to show you some images in a minute, but I also want to remind you that this is available as a podcast. You don't get to see the images, but if you want to listen on your commute, you can listen to the podcast wherever you stream your podcast. Just give a search for Adam Chilton and you should find it. I'll be posting those links to each of the podcast servers soon. Let's take a look at some images. Oh, I wanted to give you an update because Chandra was in safe mode. There was a problem, and Chandra went into safe mode the other day, and I didn't know why at the time, but now I do. So, let me show you the image of the spacecraft. Okay, the spacecraft is here. There are these gyroscopes that move around and cause the spacecraft to move, and that's how it aims. And it has these little wheels that spin, build up momentum, and then that's how it turns around and points. But there was a problem in one of those wheels, and that caused the momentum. It caused the computer to think the momentum was building up to a point where it shouldn't, and so it shut everything down in safe mode. Chandra is 19 years old. I just said it launched in 1999. Its original lifespan was 5 years. And it's been up there for 19 years doing science this whole time. So let's take a look at these parts of the spacecraft. Of course, we have the solar panels, which is how it gets its power. Originally, there were going to be more mirrors and to allow it to collect more light, but when NASA was restructured in the 90s, they reduced the number of mirrors, so they had to compensate by attaining a higher orbit. So there are 4 mirrors, and then there's a tube that goes down here, and at the end is the science module that processes the image. And let me show you what that looks like. This is an animation of the light going into the telescope. It really is amazing, Paula. The latest image from Chandra. Now remember, Chandra is collecting X-rays, so these are not visible light. But it detected something that was interesting in this area of space here. And what you're seeing in the middle is the optical and infrared from Hubble, and then up the purple ones up near the top are the Chandra data. And notice that this is over different amounts of time. So this is taken at one point, and then this one is taken later. And you can see that there are 2 sources of X-rays here, and then not so much here. One is fading. And what they've done is looked at this information with other Hubble information and have determined that it's similar to what they would expect if two pulsars or two neutron stars collided, something like this. Here is another set of images. This is the Perseus cluster. This is the Hubble data. This is the Chandra data. And this is the composite data. So one of the things that I take away from this is that, you know, the Chandra and the Hubble are each amazing instruments on their own. But when we put them together, they're so much better. I think that's true for a lot of things in life. You know, if we find the right tools and use them together in the right ways, we can get some really amazing results that unlock some secrets that we didn't even know were there. All right. That's it for the Chandra X-Ray Observatory. I will be talking about the other observatories in the Fleet of Great Observatories in the coming weeks, including Hubble, Compton, and Spitzer. In the meantime, make sure that you share this with your friends, look for the podcasts, and don't forget to look up and enjoy the night sky. Okay, until I see you again, have a great night.